Hi doctor, my name is Idzni Nashuha and I will be discussing on the investigation of KLA via bioreactor operation. So I will be explaining about the material and method in this experiment. So the materials that we have used is nutrient broth, nitrogen gas and also air. And we have done two methods, which was the calibration of dissolved oxygen electrode and static method. So in calibration of dissolved oxygen electrode, the PO2 electrode was polarized before the calibration. It was then repeated at any time when the electrode was disconnected from the amplifier for more than 10 minutes, which included zero and slope calibration. The calibration of the PO2 electrode was made in the culture vessel after being autoclaved and under the condition of the fermentation. And for the static method, the reactor was filled with 2 liters of the nutrient broth, and the airflow was connected to the reactor and turned on. The DO probe was polarized, then it was calibrated and placed in the reactor. For the LabQuest software settings, sensor calibration and optical DO was chosen. The first aeration rate parameter was set up at 1.0 liter per minute and prepared for 2 points calibration. The agitation parameter was set up at 100 rpm and the temperature parameter is set up to the acquired operating temperature. Then, nitrogen gas was pushed on the system until the value of partial pressure of oxygen inside the system becomes 0%. The nitrogen gas valve was then closed and the tube attached to the equipment was detached from the reactor. The pump was then switched back on, allowing the aeration of air inside the reactor. The actual DO concentration was recorded every 40 seconds until the reading reached 100%. It was then repeated for different aeration parameters, which are 2.0, 3.0, and 4.0 liters per minute. And next, here are some precaution steps. There are a lot of more precaution steps, but here are a few of them. So proper personal protective equipment, especially safety goggles, should be worn when using the bioreactor. Never block Never block the exhaust to pressurize the vessel. If the vessel exhaust become blocked, pressure can build up and possibly shattering the vessel. The minimum air gas pressure that will provide adequate airflow for the application, never exceed the maximum pressure, and to avoid vessel stress crack, especially during autoclaving, never over-tighten vessel clamping screw. So from the experiment we have done, here are the data. So from the data, we did observe the airflow rate at 1.0 liter per minute, 2.0, 3.0, and 4.0 liter per minute. Then we did calculated the calculation for driving force oxygen concentration, which is driving force equals to percentage of DO at 100% saturation minus percentage of DO at respective time. Then we did calculated for lone driving force, lone oxygen concentration. Then from this data, we did plotted the graph. So this graph and this graph. So from the lone graph, we did calculated the slope for tangent on the lone oxygen concentration curve. So the direct condition is obtained by presenting the straight estimating straight line to the plotted graph of lone C star minus CL against time by using the formula y equals to mx plus c. So where the equation of straight line, where m is the slope of the line and c is the y-intercept. Next, we calculated the determination of KLA for all of the flow rate. Then we have found the discussion. So from the result obtained above, we can see there are several sequences to obtain the KLA value, which are used for comparing the efficiency of bioreactor. The different value of airflow rate liter per minute are used, which are 1.0, 2.0, 3.0, and 4.0 respectively, to see the effect on the KLA determination. This is because the KLA value are affected by several factors, including the airflow rate. Due to the result obtained, determination of KLA must start with driving force calculation, where it involved the saturation concentration of the dissolved oxygen in liquid phase, or known as equilibrium solubility, which is the C star, and the concentration of dissolved oxygen in the liquid phase, which is the CL. According to results, the dissolved oxygen value are higher at high value of flow rate, which The value of DO for 4.0 liter per minute air flow rate at the time interval 40 seconds is 88.9% and the highest at 520 seconds, which is 91.1%. While for 1.0 liter per minute air flow rate at 40, the DO percentage value is around 5.9 and the highest is 97.9 at 1360 seconds. These results show that the dissolved oxygen concentration are constantly affected by the aeration rate. Due to the graph ln C star minus CL against time, the value of KLA could be determined by the slope of the linear equation. The value of slope for all graphs are in negative value because the driving force or oxygen concentration is decreasing when the time increases. As the time increases, the DO level also increases and the highest value of the value of DO known as saturated condition. The saturation concentration will be used as the initial benchmark for C star minus CL at time 0. So that's all for me. Thank you so much.